So today we're going to finish up the last part of section 4. So today is 1.4c, and today the method that we're going to learn how to use to solve quadratic equations is using the quadratic formula. And the quadratic formula is x is equal to negative b, or the opposite of b, plus or minus b squared minus 4 times a times c, and that's all under the square root, divided by 2 times a. The key thing here is your equation must be in standard form, so you have the correct sign on your a, your b, and your c. The a will always be the number in front of x squared. Your b is always the number in front of x. And your c is always going to be your constant. So if your given equation is not in standard form, you have to fix it. And then you plug it into the formula. Pretty good. I know you had to copy down the formula. All right, let's try 5 examples using this formula. So the first thing I'm going to do is I'm going to identify my a, my b, and my c. Now, my equation in number 1 is already in standard form. Just for a quick reminder, I'm going to write the quadratic formula right above the problem. So opposite of b plus or minus b squared minus 4 times a times c, that's all under the square root, divided by 2 times a. So in this particular problem, my a value is 1. Now when I go to get the rest of the values, I'm taking, if it's a subtraction sign, my b value right here is a negative 4. So this is where you have to be very careful. My c value is the constant, so my c is going to be 2. Now that I've pulled out a, b, and c, all I do is substitute them into the formula and follow PEMDAS. So again, opposite of b, so b is negative 4, so what I put in here first is positive 4, or you could put it in as a negative negative and it turns positive, plus or minus negative 4 squared minus 4 times a times c, that's all under a square root, divided by 2 times a. I now need to simplify what's under the square root first. So 4 plus or minus 4 squared, negative 4 squared is 16. And now the way that I do this is I treat this 4 as a negative 4 times a 1 times a 2. You could treat it as positive and put the sign in there as subtraction, but if you get a negative when you multiply, make sure you change it to positive. So it's easier for me to just say I'm multiplying negative 4 times positive 1 times positive 2, and that gives me a negative 8. And that's what I write there. Under the square root, divided by 2 times a, which is 2 times 1. I now need to subtract what's under the square root. So 16 minus 8 is 8. Now, common mistake that students make, and I'm going to see it on the test next week, is before they break down the radical, you try to simplify the fraction. Do not simplify that 4 and 2 until after you break down the radical. So we need to put 8, square root of 8 in simplest radical form. So if I break down the 8, I get 4 times 2. If you're good at recognizing 4 is a perfect square, the square root of 8 is just 2 square root 2. So now I'm going to put it in here. 4 plus or minus 2 square root of 2 divided by 2. Now is when I can simplify. Because again, remember, if I were to have pulled this apart, 4 over 2 plus or minus 2 root 2 over 2. Remember, most of our answers were looking like this. So now I can simplify the fraction. Okay. All right, so for those of you who are at home or are going to come back tomorrow, that is the new bells. They do that 3 times. So that's ending first lunch. All right, so let's go ahead and simplify here. So I can reduce this and make this a 1 and the top a 2 and make these both 1s. Now I could do it over here. Just remember this 2 that's in the denominator needs to simplify both. So now my final answer here is 2 plus or minus the square root of 2. And again, when you're going to key it in a WebAssign, you'll pull it apart. You would enter it as a 2 plus root 2 and a 2 minus root 2. That's what x equals. Let's try another. Yes.
If I couldn't simplify the, like, let's say 2 square root of 2 was 3 square root of 2, and I can only simplify the 4 with the denominator, can I still do that, or do I have to be able to simplify both the 4 and the 2 square root of 2?
If you're going to leave it with one denominator, you would have to be able to simplify both. If you pull it apart, then you could leave one a fraction and one not.
Okay.
All right, let's try the next one. It's already in standard form. My A value is 1, my B value is -3, and my C value is -2. Now that I've pulled out A, B, and C, I plug it into the equation. Opposite of B is +3, -3 squared minus 4 times A times C, it's all under the square root, divided by 2 times A. 3 plus or minus -3 squared is 9. And now I'm going to multiply -4 times +1 times -2, and that gives me +8. 2 times 1 is 2. I'm now going to add what's under the radical, and I get 17. 17's prime, I can't break it down, so there's your final answer. The next one. Do not try to say A is 2/3, B is -1/4, and then C is -3. Get rid of the fraction. Last year when we gave a test on this and we gave fractions and we were asking them to use the quadratic formula, it was a disaster. Do not try to work with the quadratic formula with fractions. It will work, but it'll be a big messy mix. So get rid of the fractions by multiplying your quadratic equation by the common denominator. So I'm going to first get it in standard form, and then I'm going to get rid of my fractions. So the first thing I'm going to do is subtract the 3 so I can get it in standard form. Now I'm going to multiply my entire equation by the common denominator. Now don't get confused with completing the square, where all we had to do was get rid of the 2/3. This one I want to get rid of all the fractions, because I do not want to have to work with that formula with fractions. So my common denominator between 4 and 3 is going to be 12. So I'm going to multiply my entire equation by a 12, and that will eliminate the fractions. So when I distribute it to the x squared term, this gives me 8x squared. When I distribute it to -1/4 x, this gives me -3x. When I distribute it to -3, this gives me -36. And when I distribute it to 0, it just stays a 0. Now I have integers for my A, B, and C, no fractions, and it makes it so much easier. So my A value is 8, my B value is -3, my C value is -36. I can now plug these three values into the formula. Opposite of B, plus or minus B squared minus 4 times A times C. All under the radical, divided by 2 times A. I now need to simplify what's under the square root. So 3 plus or minus 9, and now I'm multiplying -4, +8, and -36, and this gives me 1,152. Divided by 2 times 8, which is 16. I now need to add what's under the square root. 9 plus 1152 is 1161. Now, I need to do a factor tree for 1161. When I have really big numbers like this, I go back to my divisibility rules that you probably learned in 3rd grade. And the one that I like to use when I'm looking for perfect squares is the rule for 9. And the rule for 9 is to take the digits individually in this number, the 1161, and add those numbers. Once I add 1 plus 1 plus 6 plus 1, I get 9. If 9 will divide into that sum, then I know 9 is a factor of 1,161. So 9 will divide in here 129 times. So now I can't break down the 129 anymore. So this simplifies into 3 times the square root of 129. So let me break down the 1161 into 3 square root 129 over 16. I cannot reduce 3/16, so I'm done. Two more examples, and then the rest of the time you can work on your homework. Now, number 4 is a trick question. At first glance, you're thinking, oh, that's in standard form. But remember, the correct order for standard form is the x squared term, then the x term, then the constant, and it equals 0. So make sure it's in this order. If you thought your B value was 10 and your C value was 8, you're going to get it wrong. So here, my A is 1, my B is 8, my C is 10. And now I put it into the formula. Negative B, or opposite of B, plus or minus 8 squared minus 4 times A times C, all under the square root, divided by 2 times A. Simplify what's under the square root first, and I get negative 8 plus or minus 8 squared is 64, multiply, and I get negative 40, divided by 2, subtract, negative 8 plus or minus 64 minus 40 is 24. Again, do not be tempted to try to simplify the negative 8 and the 2. Wait until after the radical is reduced or simplified. This can simplify into 4 times 6, so 2 radical 6. If you would have started with 2 times 12, you'd have to keep breaking it down till it was prime. So now under, I've got negative 8 plus or minus 2 square root of 6 over 2. Now I can simplify. This will reduce to a 1, and a 4. Final answer, negative 4 plus or minus the square root of 6. and this is x equals. One last example. For this one, we need to FOIL it first, because again, we want to make it set equal to 0. So I'll FOIL it, and I get x squared plus 12x plus 36 equals negative 2x. Move the 2x over. X squared plus 14x plus 36 equals 0. Now it's in standard form, and I can pull out my a, b, and c. A is 1, b is 14, c is 36. So opposite of b, plus or minus b squared, minus 4 times a times c, divided by 2 times a. So x is equal to negative 14. 14 squared is 196. Negative 4 times 1 times 36 gives me negative 144. 2 times 1 is 2. Subtract 196 and 144. And I get 52. I need to break down the radical. Again, do not be tempted to simplify the negative 14 and the 2 yet. Do this first. This simplifies into 4 times 13, so 2 radical 13. And now simplify the fractions. So a 1 and a 1 and a negative 7. So final answer here, negative 7 plus or minus the square root of 13. Again, for WebAssign, you would enter it as negative 7 minus root 13, negative 7 plus root 13. Again, if it's only asking you, giving you one box, in the question it tells you to separate your answer with a comma. So that is it for the examples with using the quadratic formula. This homework for the 1.4C is due Monday. The 1.4B is due tomorrow. Again, remember to show work and screenshot your score. So we have about 7 minutes. So if you have any questions, you can ask or send me a message in the chat.